Right. And then the reticular activating system, or reticular formation, or ARAS. Arousal, it's in charge of waking you up. So if that gets damaged, you won't wake up. Okay? That might account for like comas and stuff, if there's pressure on that, how you would stay in a coma. Okay? Okay. The forebrain, what's the big part of our forebrain?
The cerebrum.
Cerebrum. So all the lobes, those are part of the cerebrum. Okay? The frontal lobe is the front of the cerebrum. The occipital lobe is the back of it. Because, right, the occipital, like, when you see something, it doesn't go to your cerebellum. It's still all within your cerebrum, just the occipital lobe. Okay? So the cerebrum is the thinking, the, higher functioning. Like, humans have really large cerebrums because, we have, like, higher functioning problem-solving skills. All right. Also within the forebrain, you have the thing that connects the two hemispheres, corpus callosum. Okay, and then you have this thing, that's in charge of emotion and stuff, limbic system, and then you have I always forget which is which, but one of them's in charge of fear, amygdala, and then one of them is in charge of consolidating memories, hippocampus. Okay, turning short-term to long-term memory. When we go over the memory chapter, when we get back from break, it'll be mentioned again. Okay, the gland, pituitary gland, and then above the below the thalamus is the hypothalamus, which is in charge of what?
And endocrine system.
The pituitary, which is the endocrine, and the 4Fs. Fighting, fleeing, feeding, and mating. Okay? Alright. So, and it's in charge of the pituitary gland, and remember Pitbull is the master. So he's the master of the endocrine system. Okay? Cool. Alright. Remember the pineal gland?
Yes.
What was that in charge of secreting? Melatonin, to regulate what? Circadian rhythms and sleep. Yes. Okay? It's all coming together. Yay. I think we got all of the brain, right?
Yeah.
See, the brain's like nothing now, right?
Yeah.
All right. That's a real brain.
That's so gross.
I wonder if I could get some kind of grant where we could like dissect a brain.
Is it really that color?
I took out, in AP Bio, we dissected a fetal pig, and it was sort of like pinkish, peachy colored.
Sounds probably dry. Never eat peaches.
Yeah, I mean, obviously there's no
color
blood in it. Huh?
In crayons, they always color in pink, so I just...
Yeah, or like pinky of the brain. Yeah. Okay, so the 4 lobes, frontal is thinking, temporal, hearing, occipital, seeing, eyes in the back of your head, parietal,
feelings,
touch, right? And then you have the cortexes. So over here, part of the parietal is what? Somatosensory cortex, okay, which handles, touch. And then right in front of it, motor cortex, which handles movement. Technically, the motor cortex is part of your frontal lobe, but it handles movement. Okay? The motor cortex. So remember we talked about motor strip dominance. Remember you took that little test that said if you were left motor strip dominant or right. So if you do things with your left hand, what part of your motor strip is being? If you do things with your left hand, the right motor strip, right? So remember, everything gets switched to the opposite side. When you see something, if you see something out of your left eye, where does it go? Your right side. Okay? Left side of the brain has Broca's and Wernicke's. Broca's is in charge of what? Speech production. If it's Broca in, you can't talk, right? Wernicke's is right behind it, and it's in charge of comprehension. Broca's is technically in your frontal lobe, even though it's on the side. Wernicke's is technically in your temporal lobe, okay? And they're on what side of the brain? Left. Okay? When you see something, the images get crossed in the optic chiasm, and then they go to the thalamus, and then they go occipital. Good. Plasticity. As we learn new things or don't learn new things, the brain physically changes shape. Neurons do too. If you don't use it, you lose it because neural pruning occurs, right? Okay, good. Remember Ramachandran and the mirror neurons? So when you see, let's say like you see someone getting hurt and you kind of feel it a little bit because you have mirror neurons that get activated when you see others doing things. What is the purpose of those?
Survival.
Observational learning.
Observational learning, imitating others, which ultimately survival, but you got to get the step before that. Okay, so that way we're able to learn and imitate others. Let's see. If you have a phantom limb, remember people who have phantom limbs often feel cramping, but there's nothing they can do about it because their limb is not there. So what did he do? The mirror box, right? And then because you're seeing like as though that's your hand, so your mirror neurons go off, so you feel relief. Wasn't that part so cool?
Yeah.
I love that stuff. All right. Roger Sperry, he's just someone who did split brain research. Like, you know, when the corpus callosum is severed and they have to look, like, just like, remember the thing with the Archimboldo paintings where they saw the face made out of the vegetables, and depending on what side they looked on, they either saw a face or they saw vegetables. Remember that? The ability to recognize faces, what side of the brain? Right side. What is it called when you can't recognize faces? Prosopagnosia. And just not being able to recognize objects? Agnosia. Okay, which side of the brain is more linked to like creativity, visual, spatial, right? And the left is more what? Logic. Good. Language. Language is left, okay? Because Broca's and Wernicke's are left. The endocrine system. What gland again? Pituitary. I mean, pineal's part of it, but the main gland in the brain is pituitary. Pitbull, right? Okay. Yeah, pineal is part of it. What's secreted by the pineal again? Which one? Melatonin regulates what? Circadian rhythms. Okay, that's a chapter 5 thing. Okay, so hypothalamus is the boss, then tells the pituitary gland is the master gland, triggers other things. Fight or flight, what hormone gets released? Adrenaline, yeah, you guys probably know this already, okay? And then what neurotransmitters? Fight or flight, norepinephrine, and epinephrine, okay? Alright. Glands secrete hormones. Remember, hormones are chemicals in the body. Neurotransmitters are more so the chemicals in the brain, okay? Heredity. So DNA. How many chromosomes do we have? 46, 23 from each parent, okay, generally speaking. If you're talking about eye color and you have big B, that means a brown-eyed from each parent, okay? What kind of, is that homozygous or heterozygous? Homo, same. Homo means same. Big B.
Oh.
Okay? So think of homosexual, heterosexual, male and female, they're two different, right? Homosexual, let's say 2 males or 2 females, are the same. So big B would be homozygous, big B, little b would be heterozygous, okay? Okay, I have brown eyes. What is that? Phenotype. But I have big B, little b. What is that? Genotype. You can't see it. Okay? If someone's blue eyes, you're going to know their genotype. Because what is it?
Little b,
because it's recessive. Yeah. Okay? I guess that's why brown-eyed people are so mysterious. All right. Twin studies. Identical twins, remember the egg is split after it's fertilized, so they share 100% of the same DNA, okay? Fraternal twins, 2 separate eggs, 2 separate sperm. They're just as alike as regular brothers or regular brother and sister, they just happen to be born at the same time. Alright, that's why they might look more alike to people, because they're always the same age. So like, if you have a sibling and they're different age than you, you never totally look alike, but your parents might be like, oh, you know, you look like him when he was a little baby, right? But if you were at the same age, you'd look more alike, okay? So identical twins, they're going to look more alike because they're 100% the same DNA. One might be taller than the other, but that's an effect of the environment, okay? Either the environment in the womb or the environment after, you don't know, both. All right, the best thing to determine heredity and environment is identical twins raised apart. But if you're asked which is best to figure heredity and environment, and they give you twin studies, adoption studies, family studies, blah, 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 what is it?
Adoption.
Adoption, yeah. Because twin could mean, you know, fraternal, and if they're raised together, it's not going to tell you much. Adoption studies, you're separating the impact of heredity and environment because you're raising someone in a different environment, and so if you compare them to someone who shares more DNA, who is raised in another environment, you're better able to isolate those effects. Clear? Okay. So if I were to say, okay, identical twins raised apart, they share the same IQ. What does that say about IQ? Correct. Okay. Identical twins raised apart. One has a keen sense of fashion. The other one doesn't. Environment. Oh, that's it. That's bio.
Oh, okay.
It wasn't bad. Yeah, I'm telling you, after you go over it again, like you realize how much you know, and it's not that bad. Any questions on bio? Nothing? Are we good? Did you guys want to do more, or 5 minutes? Are you getting pretty tired? I won't be offended though. Should we call it a day?
What's number 4?
Chapter 4 is sensation and perception. Monocular cues.
Yeah, we just did that.
Pretty much.
Yeah.
I think we did that starting in October. So, yeah.
Maybe just like the ear, like timber.
Oh, yeah. Okay, so we could do the eye and the ear and all that. Okay. Or you just want the ear?
Well, the ear's the one that confuses me most.
Should we just do the ear then?
Start off and then we have time.
I actually heard that timber song on the radio as I was pulling in tonight.
Me too.
Did you? Bye, Adriana. No problem. Okay, sensation perception. You guys remember absolute threshold, just the difference, right? Okay, so let's go to the ear. You know signal detection theory? Sensory adaptation. Okay, I'm going to the ear. And then if there's anything else you guys need help with, let me know. We'll go 12 tomorrow, okay? Where are you? Ear. And remember, all these PowerPoints are on my website, so. But you're better off looking at your notes, because sometimes I add stuff to it, so. Yeah. Okay, hold on. Jeez, this is a lot, huh? Okay, here we go, sound. All right, so amplitude, think of altitude, how high you are in the air. That's how high the wave is, and that's loudness, okay? So amplitude is loudness, measured in decibels. Frequency, how fast the things go, okay? And that's measured in hertz, okay? And that's the pitch. Think of a really high-pitched sound hurting you. High-pitched hertz, okay? Purity, remember I said that song Timber by Kesha because she's impure, so purity and timber. And then when you get older, you have trouble hearing high frequency sounds. So that's why like your grandfather really can't hear your grandmother. It's not just making it up. Okay, so that's when you get older, it's harder to hear high frequency sounds, okay? We know high decibels can damage ears, that's common sense. We can hear from 20 hertz to 20,000 hertz. If it's above or below, humans generally can't detect it, okay? Other animals might be able to, but not us. Okay, so any questions on that, or is it just a matter of memorizing? Okay, just the Kesha thing helps with that. For me,